My name is Srinivas Govada. I am working as assistant professor in IARE college. Today we will say about the DBMS storage systems. Databases are stored in file formats which contain records. At physical level, the actual data is stored in electromagnetic format of some device. The typical storage device can broadly categorized into three types. One is the primary memory, secondary memory, tertiary. The capacity increases going downwards, whereas the speed decreases. Okay, it decreases. At the primary memory, you will have more speed compared to tertiary memory. Okay, this is the primary storage. The memory storage that is directly accessible CPU, like RAM or internal memory, and this will be directly accessible CPU, and they are placed on the motherboard or CPU itself. This storage is typically very small but ultra fast and volatile. Primary storage requires continuous power supply in order to maintain its state. In case of power failure, all data is lost because everything is stored on the memory chip, and if the power failure, entire is volatile lost. Secondary storage. Secondary storage are used to store data for future use or backup. Secondary storage includes memory devices that are not part of the CPU, chipset, or motherboard. For example, magnetic disk, optical disk, hard disk, flash drives, and magnetic tapes. Third is the tertiary storage. Tertiary storage is used to store huge volumes of data. Since storage devices are external to the computer system, they are the slowest in speed. These storage devices are mostly used to take backup of an entire system. Optical disk and magnetic tapes are widely as tertiary storage. Memory hierarchy. A computer system has a well-defined hierarchy of memory. A CPU has a direct access to its main memory as well as inbuilt registers. The access time of the main memory is obviously less than the CPU speed. To minimize this speed up mismatch, cache memory is introduced. Cache memory provides the faster access time and contains data that is frequently accessed by the CPU. The memory with the faster access is the costliest one. Large storage devices offer low speed but less expensive. However, they can store huge volume of data compared to CPU register cache. CPU can hold less memory, it will be fastest, but it has less memory. Whereas the largest storage can offer you more memory, but they offer a low speed. Because they are less expensive also, they can store huge volumes. And hard disk drives are most commonly secondary storage devices in present computer system. These are called magnetic disks because they use the concept of magnetization to store information. Hard disk consists of metal disks coated with magnetizable material. These disks are placed vertically on a spindle. The read-write head moves in between the disks and is used to magnetize or demagnetize the spot under it. A magnetized spot can be recognized as 0 or 1. Hard disks are formatted in a well-defined order to store the data efficiently. A hard disk plate may have many concentric circles on it called tracks. Every track is for the different sector. A sector on the hard disk stores typically 512 bytes of data. Now we'll see the redundant data of independent disk, or also RAID, also known as RAID. RAID or redundant array of independent disks is a technology used to connect multiple secondary storage devices used as single storage media. RAID consists of an array of disks in which multiple disks are connected together to achieve different goals. RAID level defines the use of disk arrays. RAID 0. In this level, stipulated array of disks is implemented. Okay, the data is broken down into blocks, and the blocks are distributed among the disks. Each disk receives a copy of data to be read and write in the parallel. It enhances the speed and performance of the storage device. There is no parity and backup in level 0. In this level 0, there is no parity and backups. It is done in parallel, read and write. Okay, this is the RAID 0. RAID 1. RAID 1 uses the memory uses the mirroring technique. When the data is sent to RAID controller, it sends a copy of data to all the disks in the array. RAID level 1 is also called as mirroring and provide 100% redundancy in the case of failure. This is one copy, this is one copy. When this is failed, automatically it is fetched from here. This is 100% redundancy and can be used in failure. RAID 2. RAID 2 records error correction code using Hamming distance for its data stripped on different disks. Like level 0, each data bit in a word is recorded in a separate disk, and ECE codes of the data words are stored on different sets disk. Due to its complex structure and high cost, RAID 2 is not commercially available. RAID controller A and B. Here we have the error code correction codes. RAID 3 strips the data into multiple disks. The parity bit generated for the data word is stored on different disks. This technique makes it to overcome single disk failure. Okay, there is something called parity generator and it is stored differently. This makes it overcome the disk. If the disk fails, directly you can use on disk. Okay, this is using parity. RAID 4. In this level, the entire block of written is written on the data disk, and the parity is generated and stored on different disks. Note that level 3 use byte level stripping, where level 4 use block wise stripping. Level 3 uses byte wise stripping, where level 4 uses block level stripping. Both level 3 and 4 requires at least 3 hard disks to implement RAD. You require at least 3 hard disks to RAD controller, parity generator A and B. This is block priority, block 0, block 1. RAID 5. RAID 5 writes the whole data into a different disk, but the parity bits generated from the data blocks are distributed among all the data rather than storing them on different dedicated disks. Writes whole data blocks in a different disk, but the parity generated for each block are distributed among the data disk. It have same instead of having separate. Okay. Got two more. RAID 6. RAID 6 is an extension of level 5. In this level, two independent parities are generated and stored in a distributed fashion among multiple disks. Two parities provide additional fault tolerance. This level requires at least 4 disks to implement RAD. 4 disks. One for the error code, one for the parity. Okay. DBMS structure. File structure. Relative data and information are stored collectively in a file formats. A file is a sequence of records stored in binary format. A disk drive is formatted into several blocks that can host records. File records are mapped onto those disk blocks. File organization. File organization is how files records are mapped on disk blocks. We have 4 types. One is heap file system, hash file, sequential file, clustered file system. When a file is created using a heap file organization, the operating system allocates memory area to that file without any further accounting details. File records can be placed anywhere in that memory area. It is the responsibility of the software to manage the records. Heap file does not support any ordering, sequencing, or indexing on its own. Sequential file organization is every file record contains the data to uniquely identify that record in the record. In sequential file organization, records are placed on the file in some sequential order based upon the unique key file or research key. Practically, it is not possible to store all the records in physical form. Next is the hash file organization. Hash file organization uses hash function computation on some fields to the records. The output of the hash function output of the hash function determines the location of the disk block where the record has to be placed. Cluster file organization. Cluster file organization is not considered good for large databases. In this mechanism, the related records from one or more relations are kept in the same disk block. That is why the ordering of records is not based on primary key such key. File operations can be together. Update, retrieval. Update operation changes the data value by insertion, deletion, and updation. The retrieval process, on the other hand, not alter but only only retrieve them after optional condition filtering. In both type of operation, the selection plays a significant role. On other than creation and deletion of file, there could be several operations which can be done on files. Open. What are those? They can open. A file can be opened in one or two modes, read and write. In write mode, the operating system does not allow anyone to alter the data. In other words, the data is read only. File open and read mode can be shared among other entities. Write mode allows data modification. File can be opened in write mode and can read but not be shared. Locate. Every file has a pointer. It tells the current position where the data is to be read or written. The pointers can be adjusted accordingly using find, seek operation. It can move forward and backward. Read. By default, when files are open read mode, the file pointer points to the beginning of the file. These are options where the user can tell the operation where to locate the file pointer at the opening of the file. The very next data file is read. That's right. User can use to open a file write mode when it enables them to write contents. It can be deletion, insertion, or modification. The file pointer can be located at the time of opening or can be dynamically changed in the operating system. Close. This is the most commonly important operation from the operating point of view. When a request to close the system is the following: it removes all the locks in shared mode, saves the data, release the buffers, the organization of data inside the file plays a major role here. A process to locate the file pointer to desired record inside the various file are arranged sequential and clustered. Thank you. This completes the file storage.
Like, share and subscribe. Hit the bell icon for more updates.